So let's see the different set of examples in today's session where we're going to connect linear equations in one variable connected to the geometrical structures like the rectangular field or the square field or the triangular field. So different geometrical structures where area and perimeter are the related concerns connected with linear equations in one variable. So today's session is about connecting area and perimeter to the word problems, applying linear equations in 1 and 2 variables. Now, when I just have this problem, the length of a rectangular field is 8 meters less than twice its breadth. If its perimeter is 56 meters, then I want to find the length and the breadth of the given rectangular field. So in this case, I just picturize by drawing a rectangle and then the dimensions, then convert all the given information into the mathematical equations. Then I solve the linear equations, the solution of which will give me the dimensions of the rectangular field. So for that, first initially I just draw a rectangular field. As we all know that rectangle is with opposite sides equal and parallel, and of course each of them angle is 90 degrees. So using this, if I assume this to be the length, then this would be the breadth or the width of the rectangle. Now let's take the given conditions out here in the mathematical form. Now the information here says that the length of a rectangular field is 8 meters less than twice its breadth. So if I double the breadth, then length is 8 meters less than of twice its breadth. So this is how I get the mathematical equation of by converting the word form into the mathematical form. So length is twice its breadth minus 8. So 8 times less. 8 meters less. Next, this is one of the condition where from this 2b minus 8 is L, so that I get 2b is L plus 8. I want to take 2b to the left and then minus 8 when it comes to the right would be plus 8. Therefore 2b is L plus 8. Is one of the equation I have obtained from the first condition given in the problem. Now coming to the next condition, it is given that the perimeter is 56 meters. So if the perimeter is 56 meters, then immediately I understand the formula for perimeter of a rectangle as twice of L plus B. So using the formula for the perimeter of the rectangle, I get this as 56, so that my L plus B is 28. So I get L plus B as 28. Yes. Now you can substitute them with simultaneous solving of L and B, or you can substitute for L here. I have L is 2b minus 8, which I can substitute in place of L out here. So that this L is replaced with 2b minus 8 plus B is equal to 28. So in this way I get the value of B, which in turn when substituted gives me the value of L. So there are different ways of substitution of the linear equation of one equation into the other, or taking them column wise and then solving them. So in this case I find that 2b plus b is 3b, and minus 8 when it comes to the right it will be plus 8, so that I get 3b is equal to 36. That implies b would be 12. So I get the value of b as 12. So once I got the value of b, then I substitute this b in one of the equation, then I get the value of L. So you can substitute either in this or in this, whichever is the easier equation. So I don't mind substituting the value of b here. So in this case I get L equal to twice of b minus 8. So twice of b, which is 12, minus 8. This would be 24 minus 8, which would be 16. Therefore my length is 16 meters because the units are given as meters, and my width would be 12 meters. So these are the dimensions of the rectangular field which is required with the given conditions. So this is how we find the connection of area and perimeter linked with finding the dimensions and then using the linear equations as one of the applications. Now let's see the age related problems, how linear equations are connected to the problems where ages are considered. Now taking this example where Rahul and Lakshmi's ages are in the ratio 5:7, 4 years later, sum of their ages will be 56 years Now I have to find their present ages. So there are two people, Rahul and Lakshmi, whose ages are given to be in the ratio. If I denote Rahul with R and Lakshmi with L, then the ratio of their ages is given to be 5:7. R represents Rahul's age, L represents Lakshmi's age, and the ratio is 5:7. So with their ratios being in the ratio 5:7, I understand that Rahul's age would be 5x and Lakshmi's age would be 7x, taking x as a constant. Now in this case, R is referred to Rahul's age and L is referred to Lakshmi's age, and here the x I have taken is a constant. Now with this consideration of R as 5x and L as 7x in the ratio of 5:7, there is one more condition which is given here. It is said that 4 years later, so that is after 4 years, sum of the ages would be for 56 years. So 4 years later, Rahul's age is going to be 5x plus 4 with 4 added out here, and Lakshmi's age would become 7x plus 4 with 4 added because it's 4 years past after in the future. Now it is given that the sum of the ages after 4 years is 56. So this plus this would be equal to 56. Now I would like to extract the value of x. This is a linear equation in one variable, which is x. So I can solve that by taking x on one side and all the remaining constants on the right hand side. So I take 5x plus 7x, I get 12x by adding the x terms, and then 4 plus 4 is 8, which is equal to 56. Now in this case, 12x equals 56 and plus 8 to the right comes as minus 8, then this would become 48. So my x would be 48 by 12, which is 12 fourths. So therefore my x value is 4. So using the value of x equal to 4, I would like to find the Rahul and Lakshmi's present ages. Now keeping in mind their present ages are 5x and 7x, not 5x plus 4 and 7x plus 4, because this would be after 4 years. So taking the present age, Rahul's present age is given by 5x, that is 5 times of x, which is 4. So 5 times of 4, that is 20 years. So Rahul's age would be 20 years, which is his present age, and Lakshmi's present age would be 7x, which is nothing but 7 times of 4, and that is 28 years. So this is Rahul's present age, and this is Lakshmi's present age, which we have totally found out using the linear equations. So this is one of the application in real life where linear equations are also used in age related problems. Now this is an interesting problem where we are going to find the number of questions a student has attempted in the test correctly or incorrectly. So this kind of problems lead to an interesting understanding by the student on how much of linear equations can be used in real life. So let's read the question. The question says that there are 180 MCQs, the multiple choice questions in a test. A candidate gets 4 marks for every correct answer, and for every unattempted or wrongly answered questions, 1 mark is deducted from total score of correct answers. If a candidate scored 450 marks in the entire test, how many questions did he answer correctly? So it's very interesting, which we can predict using linear equations. So if you don't have the linear equation concept in mathematics, I think this problem would not have been that easy to be solved randomly to get the exact answer. So let's see how we can do that. So if you frame the question, we see that the total number of MCQs are totally given in the test is 180. Now it is also given that a candidate gets 4 marks for every correct answer. So one correct answer will lead to 4 marks. So that is the information given here. And for every unattempted or wrongly answered questions, 1 mark is deducted. Okay, let's come to that next. But we don't know how many answers are correctly written by the student. So I'll just take that as X because that is what I need to find here. So let number of questions with correct answers in the entire test be X. So let me take the number of questions with correct answers written by the student as X in the entire test. Now, therefore, if I've taken the number of correctly answered questions as X, then the number of wrongly answered questions would be 180 minus X, because the total number of MCQs are 180, and if the number of correctly answered questions are X, then out of 180, if I remove that X, then the remaining would be the wrong answers or unattempted. So number of wrongly answered questions would be 180 minus X. So, or you can also take unattempted, because there might be some chances where the student has not attempted itself. So that comes under wrong. Is 180 minus X. Now, from this, I understand that for one correct answer, it is 4 marks. So in this case, if there are X correct answers, so how many marks would the student get on the whole on the correct answers? So for X, let me revisit this. For one correct answer is 4 marks. So X correct answers would be 4X marks, 4 times of X. Now using this, I would like to just use the condition of here where it says that for every correct answer, for every unattempted or wrongly answered questions, 1 mark is deducted from total score. Now this is very important. So for every unattempted answer, 1 mark is deducted from total score of correct answer. So here I read that for every unattempted answer, unattempted or wrong answer, one mark is deducted from total score of correct answers. Now I have taken the number of correct answers with one correct answer is 4 marks. So totally number of marks which the student gets is 4x marks. So using this, I understand that if I have 180, totally I have 180 minus X wrong answers or unattempted answers. Therefore 180 minus X wrong or unattempted answers so I totally get 180 minus X, because for every wrong answer 1 mark is deducted. So for 180 minus X wrong answers, 180 minus X marks are deducted from the main 4x marks. So I get, now it is given that the candidates totally scored 450 marks. So if the total marks the student has got is 450, then this is nothing but the whole of the correct answers which he has got with 4x marks minus 180 minus X marks, which I'm going to deduct using this condition. For every unattempted or wrongly answered questions, 1 mark is deducted from total score. So 180 minus X marks are deducted overall from the total score from the correct answers using that condition of the statement. Now this is nothing but 4x minus 180 plus x is 450, which on simplification gives me 5x minus 180 by adding the first and last term, that is equal to 450. That implies my 5x would be 450 plus 180, with minus 180 coming to the right as plus 180. So my 450 plus 180 is 550, 630. So that my x would be 630 divided by 5, which gives me 126. Therefore, I understand that in the test, how many questions did the student answer correctly? So I totally understand that the number of correctly answered questions is 126. Therefore, the student answers 126 answers exactly correct out of the total 180 MCQs. So this is an interesting question where linear equations are used as real life applications through the test problem which we have seen in this example. Now let's see a problem where the digits are reversed. In this case, we need to use the concept of numbers into consideration in these kind of problems where we are going to connect with linear equations, of course. Now let's see the problem. A number consists of 2 digits whose sum is 9. If 27 is subtracted from the number, its digits are reversed, then find the number. So in this case, I have to have some knowledge on a 2-digit number. When I say a 2-digit number, say a 53, I can write this as 5 times of 10 plus 3, because this is in the units place and this is in the tens place. So 53 can be written as 5 times of 10 plus 3, and similarly 47 can be written as 4 times of 10 plus 7, etc. So using this concept of a 2-digit number, so a number consists of 2 digits. So let the 2-digit number which I'm going to take be in the form, let the 2-digit number be in the form 10x plus y, where x will be the digit in the tens place and y will be the digit in the units place. So taking this, using this kind of a pattern which we have identified in some example problems of a 2-digit problem, I get a 2-digit number to be in the form 10x plus y using this kind of a concept. Now a number consists of 2 digits and it is said that the sum of the 2 digits is 9. So if x is the first digit and y is the second digit, then the sum is 9 using the condition from the statement. Next, if 27 is subtracted from the number, now the actual number is 10x plus y. So if 27 is subtracted from the whole number, which is 10x plus y, I get this equal to, its digits are reversed. So the condition says that if 27 is subtracted from the number, the digits are reversed. So y interchanges with x, they're reversed. So I get 10y plus x because x gets replaced with y and y gets replaced with x. Now, so this is strictly a linear equation in 2 variables where we are going to solve using the conditions here. So initially I'm going to solve this by expansion of brackets and bringing all x and y's to one side and remaining constants to the other side. So here in this case, I get 10x plus x, I get here it becomes minus x plus y minus 10y is equals to 27. Now 10x minus x is 9x and y minus 10y is 9y equals 27. Then this would be nothing but taking 9 common and cancelling with this, I get x minus y equal to 3. Is one of the equation which I got from this condition, the second condition of the statement. Now I want to solve equation 1 and equation 2. Then I get the value of x and y, which would give me the 2-digit number or the number which is required in the problem. So let's take equation 1 and 2 and then solve them. So my equation 1 here is x plus y equal to 9 and x minus y equal to 3. So this can be solved by adding. Now here I have two equations which I would like to solve. So I just eliminate y by adding the two equations. I get 2x equal to 9 plus 3, which is 12. So that I get x equals 12 over 2, which is 6. Now I substitute the value of x equal to 6 in one of the equation. Therefore, I get the value of y equal to 3. Now, when I substitute x equal to 6 in one of the equation, I get 6 plus y equal to 9, so that I get y equal to 3 by just simplifying further. Now, I get the values of x to be 6 and y to be 3, from which I get the number, because I know that the original number, the 2-digit number, is 10x plus y. Therefore, the required number is 10x plus y, which is nothing but 10 times of x, which is 6, plus y, which is 3. This is 60 plus 3, which is 63, is the required 2-digit number. So this way, even a reverse digit concept can also be used in applying linear equations connected to that. And the various different applications we have seen in real life should make you understand how important is linear equations in real life. Now, let's see equations which can be reducible to simple form. Now, simple equations are the equations which are linear equations in one variable. So, linear equations in one variable are called simple equations. So, let's try to convert these into simple form. Now, when you want to convert them into simple form, we try to just take LCM and then cross multiply. Most of the questions in these kind of problems, we just take the LCM and then cross multiply. Then take all x terms one side and all the constants other side. Then we get the solution of the given problem. So that, keeping that in mind, so let's start with the LCM process. Now when I have this problem, I take the LCM on the left hand side. So first let me simplify the left hand side with a step-by-step process. I take the LCM. Now I see that the LCM of 6 and 9, 3 times 2, 3 3s, it is 9, 9 2 is 18. So I identify the LCM of 6 and 9 to be 18. So that 6 times of 3 would give me 3 times of x plus 5 minus 2 times, because 9 2 is 18, 2 times of x plus 1 would give me x plus 3 by 4. Now, so once I took the LCM of the left hand side of the given problem, I just expand this using the brackets, so that I get 3 times of x multiplied, and this gives me 3x plus 3 times of 5, which is 15, minus 2 multiplied with x and 2 multiplied with 1 gives me minus 2x minus 2. It's not plus 2, but minus into plus would give me minus. This should be taken care of. This divided by 18 would be equal to x plus 3 over 4. Now, on further simplification of the left hand side, I take all the x terms and simplify. So I get 3x minus 2x as x, and 15 minus 2, which would be 13, divided by 18 would give me x plus 3 over 4. Now when I further simplify this, I just simplify using the cross multiplication concept, where this gets multiplied with this and this gets multiplied with this in the cross form, in the crosser form. So when I cross multiply, this gets multiplied with this, so I get 4 times of x plus 13 is 18 times of x plus 3. So that again, on expansion of the bracket, or before that, I just like to cancel with 2, so that the simplification becomes more easier with simpler values. Then I multiply 2, then I get this as 2x plus 13, 9 times x plus 3. Then on expansion of the brackets, I get this as 2 times of x plus 2 times of 13, which would give me 26 as the value. And then I get 9 times of x, then 9 times of 3, which would give me 27 as the value. Then now I bring all x terms to one side and all the remaining constants to the other side, so that my 2x remains on the left, and my 9x on the right comes to the left as negative 9x, and then 27 minus 26 would be the other value. Now, this on further simplification gives me minus 7x, because the sign of the greater value is negative, and then I get this to be 1. So negative 7x is equal to 1. Then this would give me minus 7x equal to 1, implies my x would be 1 over minus 7. This minus comes to the numerator as negative 1 over 7, which is the value of x. So this is how I solve the linear equations, by converting them into the simpler form, into a simple linear equation, and then solving for its value. So linear equations can be reduced to simpler form by taking LCM and cross multiplication and expansion of brackets, and finally taking all x terms to one side and the rest of the constants to the other side, then simplifying to get the final answer, as we have done for this problem. This is how we find the value of x for any fractional problem given. So let's take one more problem where we will try to convert the given word form into the mathematical equation and then reduce it to the simpler form. So let's take a question where an equation is reducible to simpler form given as a word problem. So now I'm going to give a word problem from where we are going to convert that into a mathematical equation and then solve that and reduce to simpler form and then find x, as we have done for the previous problem. So here is the word problem, which states that what number is that of which the third part exceeds the fifth part by 4. Now I'm going to convert this equation in this statement into a mathematical equation of this type and then reduce it to the simpler form to find the value of x. Now the question is, what number is that of which third part exceeds fifth part by 4? A word problem where we are going to convert this into an equation reducible to simpler form. So here, if I take the number as x, so let the number be x. Now, it is given that the third part of x, when I say the third part of x, it is 1/3 of x. So 1/3 of x, which I take mathematically. The third part of x exceeds the fifth part by how much? By 4 units, as given here. So mathematically I understand that 1/3 of x exceeds the 1/5 of x by 4. So exceeds is nothing but we add. So it is plus 4. So therefore I get x by 3. If I just rearrange the terms, I get x by 3 is x by 5 plus 4. So in this case, I have to simplify this, reduce it to the simpler form, and then find the value of x. So as we can see here, let me bring the x term to the left so that I get minus x by 5 equal to 4. Then this is as similar as this, where I took the LCM, then I took the cross multiplication, then I took all x one side and constants other side, then I got the value of x. The same thing which I'm going to do here. So first I'm going to start with LCM. This is 5x minus 3x is 4. This would give me 2x by 15 equal to 4. This on LCM gives this. Yes. Now I'm going to cross multiply the two equations so that I get 2x equals 15 fours 60. So 15 fours 60. Then this would be nothing but x equal to 60 over 2, which on cancellation gives me x equal to 30. Therefore, the required number which the question is asking for with the given conditions is x equal to 30. So like this, linear equations can be used in various branches of mathematics, and most of the topics demand for this, because until and unless you solve the given equation, you cannot find the value of x. And solving of equation is nothing but the topic which we have learned, the linear equations. And all the best for all the topics, for all the contents you're learning in this. Is very much interesting and connected, and all the best.